Right, we have the first paper. It comes from University of Potsdam, Germany. Perhaps we can start, right?
Sure.
Yes, please begin. 15 minutes, please.
Yes, hello. My name is Max, and today I want to present our work on interactive multi-level stroke control for neural style transfer. So when we think about creating tools for image stylization, we need to put the user into the focus. What does the user want in his tools? There have been several goals postulated on how to create a successful stylization tool. For example, using example-based media reproduction to guide the user along a certain style, use of interactivity, and offering different levels of control. So, for example, expert users want a low level of control, whereas more novice users typically want an easy-to-use high level of control. These goals have been mostly achieved for many existing algorithmic approaches. However, for the machine learning-based approaches and in particular for neural style transfer, there are still many open questions. And with these questions, our talk concerns with. And before I present our approach, I want to give a little bit of background on the existing approaches. So example-based stylization has been practiced for many years using algorithmic approaches. And here we can see a selection of different techniques. In the upper left, we see watercolor, then pastel and oil styles. And common in all these algorithmic methods is that the adjustable aspects of the style are manifold. So we can, for example, adjust the texture or adjust the colors or the strokes. We also typically get a very high resolution output image. However, on the downside, the styles have to be handcrafted for every new style, which is a time-intensive process. So how can we transfer arbitrary styles to new images? Here, the method of neural style transfer has established itself in the past years as a generic neural network-based method to transfer styles from a style image to a content image. While the original method published by Gatys et al. Is a slow, non-interactive optimization-based method, following works have introduced more fast modes to stylize images, even at interactive frame rates. One such method is the Feedforward neural style transfer by Johnson et al., which trains a feedforward network to generate exactly one style. There have been multiple approaches to expand this network for more than one style or arbitrary styles. However, in commercial applications, this feedforward style with one style has prevailed due to its speed and its result quality. So the neural style transfer in use in many applications typically presents the user a selection of different style images, which he can choose and then apply a style to the image. This yields quick and impressive results. However, compared to non-photorealistic rendering, we have no way of adjusting any aspects of the style. Also, the output is severely limited in its resolution by the GPU memory. On the other side, of course, we can now transfer generic styles to content images. This method has been used in many popular end-user targeted applications, for example, Prisma, Picasso, and even in Photoshop. However, the major limitation which comes from the underlying method is that there is no artistic control because the method does not allow any control, which means these solutions remain one-click only solutions. In research, there has been some effort to extend modes of control for neural style transfer. For example, for the optimization-based and slow approaches, there have been quite a few. Generally, they work by proposing additions to loss functions. For example, on the left, we see the region-based or mask-based control in Neural Doodle. Here, a semantic mask is drawn, and for each area of the mask, a different semantic is assigned, which then creates the output image we can see here. On the right, we see stroke direction control. Here, a flow field is generated, which guides the strokes along the flow. The user can then manipulate this flow by drawing on the image and generating these output strokes in the output. For feed-forward control, there has been only very few methods proposed. For example, stroke control on the left side. Here, the network architecture is extended to have different stroke sizes implemented in it in the different stroke branches. And then the output can be controlled by a parameter which specifies how large the stroke size should be. On the right, you can see previous works of ours which concerned with how to direct styles onto a content image in an interactive way. So if we have different styles, how can we blend them interactively to a new image? Common to these methods is that they all use an extension of the original architecture, and they are all tailored to one specific mode of control, which also means that combining different editing methods is thus not possible. We thus propose a user-centric approach for multivariate editing of neural style transfers, specifically for stroke orientation, stroke intensity, and stroke size. For this, we introduce a novel two-stream neural style transfer network architecture. Furthermore, we demonstrate the interactive applicability of our network using our app StyleTune for interactive editing, which includes a high-resolution upsampling step. So, compared to previous approaches, our network can now adjust 3 aspects of the style in comparison to just 1. It can generate high output resolutions, and it also, in comparison to non-photorealistic rendering, can transfer generic styles. I want to now show a quick demo of our application. So after we have selected a specific style, we now can go into the editing view, and here we can adjust the style granularity on a global level. So when we pull the slider, we can see that the patch sizes of the style is adjusted. Similarly, we can adjust the rotation of the input image. Here we rotate the image, and this in effect rotates patches in the output style. Once we have done our global edits, we can go into detail editing and apply a local edit using a brush metaphor. So here we stroke over the image to adjust the stroke size in the mountains and on the person to make them stand out from the background. Then, once we are content with our result, we can go and use a patch-based upsampling step to generate a very high resolution image. Images of up to 20 megapixels can be generated, and as you can see, there are very fine details from the style image which are transferred, such as paint bristles and canvas structure. I will now present our method. So as an intuition, our method generally relies on multiple inherent aspects of neural networks, such as the receptive field. When the receptive field of a neural network is smaller, or when it receives a smaller image, the receptive field will see a larger part of the incoming image. This, in effect, means in a neural style transfer that larger style elements are generated. Conversely, on the right, if we pass in a larger image, the receptive field will only see a small part of the image and generate a smaller style element. We use this property to dynamically resize the input image to a style branch. And resizing the style branch, in fact, creates a stroke size edit in the output image. We have another branch in our network, which uses the high resolution input image and extracts high frequency detail. These two branches are then merged together and jointly decoded to form the output image. Adjusting the stroke scale factor lambda s in the input image adjusts the scaling of the input image and then produces stroke scales in the output image. Our second mode of control is stroke intensity control. Here we use conditional instance normalization. Based on the stroke intensity factor lambda I, a fully connected layer predicts parameters alpha and beta that are then used in the conditional instance normalization formula you can see on the right. When we now adjust the parameter, we can see that the style gets more intensive, the higher the parameters is. The third mode of control is stroke orientation control. Here we once again make use of a fundamental property of neural networks, which is that they are not rotation invariant. So given a rotated image, a network will produce different activations than an unrotated image. We thus rotate the input image and forward it through the network and then rotate it back by the same angle. This, in effect, produces a stroke orientation in the output, which can be oriented by the chosen input angle. I will now show how we included this network in our interactive editing workflow. So to achieve interactivity, we pre-compute stroke features for the chosen mode of control. So for example, for stroke sizes or for orientations. And when the user starts local editing, a spatial mask is created. The spatial mask blends together the intermediate images in image space and creates an output-free preview image. Once the user is content with his results, he can then merge the features in feature space and use a decoder network to generate an output image which has a more seamless transition between stroke scales. Finally, we can apply a patch-based neural style transfer to generate output images at a very high resolution of up to 20 megapixels. This is either done on device or as a server-based task, depending on the output resolution. The patch-based upsampling method uses a method by Texler et al., and it reconstructs the generated stylization using patches from the style image. This creates a nearest neighbor field, which is then upscaled and decoded back into the output image. And here we can see that we can transfer very high detailed information from the style image. Our results show that we can apply local edits very well. A common use of this is, for example, to highlight certain areas, such as here, the face and the hair, and make it stand out from the background. And if we compare the global and edited feed-forward results with the patch-based results on the right, we can see that also local edits have been included in the patch-based result. Furthermore, we can also see that fine details such as strokes or scratches in the gold style have been transferred very well. There are, however, slight differences in the patch-based output and the feed-forward result, which may present a limitation to some artists who expect an exact matching, but in general, it is not a problem. Compared to previous methods for stroke size control, we can see that both can control the stroke size very well. However, our method is able to represent a larger range of stroke size edits because it relies on resizing the input image, which can be done in any arbitrary resolution. Of course, resizing it to a very small size will also lead to some blurry artifacts in the output image. So the stroke size is not unlimited here. Performance-wise, we perform comparables to state-of-the-art methods and can run at interactive frame rates at 1 megapixels on recent iOS devices. So in conclusion, we present a novel style transfer architecture that enables multivariate editing of feed-forward neural style transfer and gives control over several elements of the style. Our presented app demonstrates its ability to interactively edit results and create very high fidelity outputs. Our presented approach sets the baseline for future work. There are several aspects which can be improved regarding the usability for artists or adding more modes of control. A long-term goal of ours is to achieve fine-grained control over more high-level aspects of the style, such as shapes or patterns. And with this, I thank you for your attention. You can download our app on test flight, and I am now open for your questions.
Thank you very much. On behalf of the audience, I'm doing this. Do you have anybody question? Anybody want to ask questions? Please unmute yourself and ask your question. Let's make it interactive. Any questions from the real audience?
I can make one question here. How to validate such approach? I mean, except of course you show some image and show the difference between other algorithm, but how to set up an objective evaluation framework for style transfer? I know it's complex, but that's a question.
Thank you. Yes, that is a very good question. And I think it is also still an open question in the space of style transfer, because obviously it is always qualitative, and we can conduct user studies to generate preferences between different methods. And there have been some approaches to, for example, have a standardized evaluation set, which includes, for example, different levels of quality in the images, and then to compare with these. On a quantitative level, it is quite hard to find any metric which represents how good a style is transferred. Mm-hmm. So yeah, that's difficult.
Okay.
Any questions from online audience? I wonder, in your experiments, you apparently always take a photograph and then stylize it, right?
Yes.
Did you try to stylize painting, which already has strokes?
Yes, we tried that, and it also works, but it is often not as expected, and there might be like some more artifacts in it. But it also works.
But you don't have examples, right? Like if you
right
take one of most typically used styles by Van Gogh, you can take one of his sunflowers and try to somehow change direction of the strokes.
Yes, so that would be actually an interesting experiment, because style transfer always tries to preserve the content in the content image, right? So it depends on how strongly, for example, the strokes in the content image will be detected as a content, and if it's detected as a content, it will also be present in the output. So the stroke might not be oriented in another way. But if it's not, it should be also possible to orient these strokes.
Yeah, but it still will be recognizable. It will not turn it into complete mess of strokes.
No, shouldn't. It should be recognizable.
Right. Anybody want to ask one more question? We have time for one more question, please. If you don't ask questions, they also will not ask you. Make it interactive, please.
So if nobody has a question, I have maybe some
yes,
additional
please.
thing.
Yes, so you have 1 minute, 20 seconds.
This is just an example of how it can look if we generate the patch-based style transfer on device. So this is like an iterative upscaling process. And here we can see that like you can see after each resolution step that it increases in fidelity. So this is something we can show the user for a more interactive approach. And maybe in the future, even like when we draw, we can even see this happening in an interactive way. So this would be another goal we are thinking about to achieve.
Okay, thank you. Impressive. Thank you very much for your presentation. Let's prepare the next